Let's try to understand how this potentiometer works. I'll start with an example. Let's say you're building a resistor, and you want to build this resistor in this way. So you have the wire coming in, and then, as we know, a resistor is a component that opposes to the passage of current. So you find some material that has this property, it opposes particularly well to the passage of current. And then you define your, you take a piece of this material, and based on the geometry of these pieces of material, you get a certain value of resistance. For example, let's say 4 kilo. The question is, what happens if I take another pieces of wire and connect it in the middle and I make it available from the outside? Well, what happens is very simple. So if I want to draw the symbol of this, we went from one single resistor with 4 kilo. Now we have two resistors equal to 2 kilo, and we have a terminal in the middle. So in a way, we built sort of a voltage divider here. Now, what happens if I move this central terminal that is actually not fixed, but it can be moved, and I move it to 3/4 of the way from the bottom? So now it's pretty simple to understand what's going on. The resistance for the current from the entry point till the output of the central terminal is much smaller than the resistance from the central terminal to the lower terminal. So now we're going to have 1 kilo here and 3 kilo at the bottom. So you see two fundamental things here. No matter where you place this central terminal, the total sum of the two resistance has always to be 4 kilo, because that is completely determined by the material I pick and the dimension, the geometrical dimension of the material. And the other thing is that depending on where I position the central terminal, I will break down this value of resistance differently between the upper and lower resistance. If we go back looking at this potentiometer picture that we have here, it should be easy to understand why they have 3 terminals instead of 2. As we just said, we have the first 2 terminals, terminal 1 and terminal 3, for example. So the one top and bottom are just connected. Between them there is a constant resistance. And then there is another terminal, which is the terminal number 2, the one in the middle, that is actually a special terminal that taps the resistor, the internal resistor, in different positions, so it can move up and down depending on the position of the knob. So again, the resistance between 1 and 3 is always constant, but the resistance between 2 and 1 or 2 and 3 completely depends on the position of the knob.